Find the volume of the solid formed by rotating the region inside the first quadrant enclosed by the two curves. One is the first one is a parabola, so it has a minimum here at the origin 0 0. The second one is a line. So in the first quadrant, so the second one should be phi x, so also pass through the origin. So the region should look like this, and then we rotate it about the x-axis. So there is this, so the region look like this, and rotating it. So we first graph it. Is y x the origin, and we know that the parabola has the origin as a minimum, right? This is greater than equal to 0, so y is at least 0. The minimum is the origin. When x equal to 1, y equal to 1. When x equal to minus 1, x equal to minus 1. When x equal to 2 is 4, and we also have minus 4. Okay, so it should look like this. So y equal to x squared, and the second one is y equal to 5 times x. This is a line. X equal to 0, y equal to 0. So go through this point. X equal to 1, y equal to 5. So it's go through this point. The line go through the 2 points. Okay, so the region we have is this region. This region in the first quadrant, bounded by the two curves, the red and the blue one. We need to rotate this region about the x-axis. So what we will see is something like this. Every point on the blue one gives us this, and then continue. On the red one, give it a smaller circle. So what we can see is this kind of solid. Every point on the blue one give is this outer circle. So that have the outer boundary. The red one is this curve, and if we rotate about the x-axis, we will have this one. So the red one is inside, so it gives us this smaller inner circle. So it's solid here, but there is the hollow. This part is empty, the one in between the two curves. So this region is empty here. Okay, in this case, we can do the washer method. So we just slide it perpendicular to the axis of revolution. So slide it perpendicular to the x-axis. So this gives up a partition of this axis. So delta x tends to 0. So this will be the interval in terms of dx. In terms of x, we need to find this intersection point. We know this is origin because both curves pass through the origin. This point will be the intersection of two curves. This can be determined from the equation of two curves. That one gives us the value of the intersection point, and that will be the interval between 0, when x from 0 to that one. That point, say x1, y1. So that would be the interval from 0 to x1 of the outer radius. So the blue one gives us the outer radius. So for each point here, give us the outer radius. This gives us R out. So each point x, y give us the radius. So this is x, this is y. So this coordinate is x comma y. The outer radius is, for each value of x, the outer radius is the value y in terms of x. In our case, y equal to 5 times x. So R outer is 5 times x for each value of x. So that one is outer radius. The inner radius, for each value of x here, the distance from the red curve, the inner curve, to the axis of revolution give us the inner radius. R inner in terms of x is the y, the coordinate here in terms of x or y act, where y is equal to x squared. So x squared. Okay, so we know that the area of the washer, right, every point here give us. So if we slide this perpendicular to the axis of revolution, the cross section is actually a washer. So here, the washer here, the outer circle is the one comes from the blue curve, the outer curve. The inner circle is the one comes from the red curve. The radius, outer radius, is the one coming from the blue one. So this is 5 times x. R outer. The inner is inner radius come from the red curve. So this length R inner is x squared. The area of the cross section is pi times R outer square minus R inner square. So this is the cross section. The area of a cross section or a washer. So pi R outer square minus R inner square. So this one is pi times 5x square, 25x square, minus x square square, so x to the fourth. That is a cross section. So this one gives us the volume of the whole region is the integral of the area of the cross section dx, as we said before, for x between 0 to x1, where we will determine 0 to x1. Okay. The value of x1 can be determined from the equation of two curves. So x1, y1, the intersection point, point between the red and the blue curves, between y equal to x squared and the blue curve is y equal to 5x. We know one intersection point is 0, 0, the origin, and the x1, y1 is the one different from the origin. So the intersection here, this will give us 2 intersection points. So x squared equal to 5 times x, because both of them equal to y. X minus 5 equal to 0. So this gives us 2 cases. X equal to 0. In this case, y equal to 5 times 0, 0, which is the origin. The second one is x equal to 5. This gives us y equal to 5 squared, 25. So x1 is 5. The volume of the solid